All right, so let's talk about this OpsForge tool that we have developed for the COGNIT project. The purpose of this tool is to automatically deploy all of the COGNIT stack components. We have some components that pre-exist the project, like the Cloud Edge Manager, in this case of Nebula. And then over time, we have developed components to fulfill the roles that we needed for the project, like the AI-enabled orchestrator and the versioning engine. So, and the way this tool works is that it scripts a deployment that procedure that involves the use of several technologies, mainly Ansible and Terraform, but we'll take a deeper look at how these technologies are used. So it's a three-step approach. First, you have to decide if you want to run the project stack on premises or on AWS. If you want to run it on premises, you need to provide access to each of the hosts that will fulfill the roles of the project. If you want to use AWS, you need to have access to um, you need a key pair available for you to use. You need to use that in order to access the EC2 instances that will be created via SSH. Ansible, we use that SSH access to prep up the things. So if you use AWS, we will use the tool will script the use of the Terraform provider, Terraform AWS provider to set up the EC2 instances, the VPCs, security groups, all of the networking that is required by the project architecture. Then once that step is done, we will use Ansible to set up OpenNebula using one deploy, which is an Ansible collection that we have developed for installing OpenNebula automatically. We will leverage that in this project. And also, there's dedicated Ansible roles to set up each of the project's components. Then once that is set up, it's mainly like it just installs OpenNebula and the components of the projects. It doesn't really um, provide contents for that deployment. Then we have this like last step, which is the Terraform OpenNebula provider step. And the goal of this step is to populate the contents of the Cloud Edge Manager with um, one flow services templates, which is the multi VM service we use to back the serverless runtime role. Every serverless runtime will be like a one flow service that will be managed by OpenNebula. This is done through the provisioning engine, but when you deploy a serverless runtime, you need to use a flavor of a serverless runtime depending on the use case, and we provide the ability to pre-populate the Cloud Edge Manager with these flavors that you can pass to the tool. We also have a parallel deployment, or you can say workflow, that allows you to automatically build these use case appliances using SUSE as a base distribution, and Kiwi with which is the tool that we are using to bootstrap the serverless runtime application component within the SUSE distro. And in order to use this tool, you need to create a YAML with certain information. We'll showcase that now in a demo with a slide. Okay, so we have, this is the GitHub project root folder. You can see, yes, this is the GitHub repository. You download it, and then in order to run it, you have this executable called OpsForge. This is a Ruby script, and it will script. You have two options. You can use deploy, and then you pass a YAML as an argument, and then let's use the help, for example. Yes, and then you can use the build the SAR approach to run to automatically build the runtime appliance. So let's first take a look at the YAML. I have like several examples. These are not part of the GitHub repository. These are git ignore because it contains sensitive information. So let's take a look at a complete YAML, all of the things that we can use. There's a schema that you can take a look at if you want to to view all of the features that you can or the possibilities that you can have with this YAML. But let's take a look at a big one. This one is for deployment on AWS. You need to pass. This is the SSH key name that you will be selecting when running the EC2 instances. This is the public key path or the private key that matches that key and your local file system. And these are configuration options that you can set up for the EC2 instances. This is where the image will be pulled from, like the result of building this image you can pass a host to it where you want to build the SUSE image, and then you can publish that image on a publicly available web server that you can then use to pass it on the YAML. You can also pass SSL certificates for the Cloud Edge Manager front end. If you don't pass them, these will be automatically generated by an Ansible role as well. Then you can specify the versions of the things you want to use, and in this case, you'd also need to pass the token because we require the enterprise edition of Nebula to deploy this, since we need Prometheus as one of the project components. So that's a big YAML. Let's take a look at a simple one now. If you don't pass values, a lot of defaults will be assumed. In this case, the token cannot be a default, and I'm just specifying the region and my name on my AWS account. And by default, it will look for the SSH key and on this path. So let's talk also about the dependencies, because we have some dependencies. As I mentioned, this is a Ruby script, so Ruby is a dependency. So you need Ruby plus this gem, which validates the JSON. You need Terraform, you need Ansible, and if you use if you're going to use the AWS deployment, you also need AWS CLI setup, because that is a requirement of Terraform itself. So the script will run, and it should validate that you have all of those dependencies before attempting to deploy, and then it will run. Let's take a look at the deployment of the YAML. So first, as I mentioned on the previous slide, it will try to set up the infrastructure on AWS. Right now, you can see it's planning what is attempting to do. You can see there's a lot of gateway definitions. It also sets up the VPC. You could have an error that each region has a VPC limit. So if you have reached the VPC limit, it is possible that you can see this error. You just need to change the region or VPCs. But on its own, it's just creating a bunch of AWS resources, mainly EC2 instances, and all of the requirements for these EC2 instances to be usable. The instances itself is one for the provisioning engine, one for the AI orchestrator, one for the Cloud Edge Manager, and there's also an extra one, which is a sort of ingress controller that we created in order to have this. It basically is a reverse proxy that hides all of the infrastructures behind it, and also as a NAT gateway for all of these machines. The cool thing about that is that you just need the one public IP instead of having each and every one of the project components publicly available with a public IP address. With the reverse proxy, we can just redirect if you want to have issue a call to the provisioning engine. The reverse proxy will act as a front end, and then we'll redirect internally. The same with the Cloud Edge Manager user interface, and also the other user interface that we have as well. So it's a cool way to abstract the rest of the infrastructure. So right now, you can see this Ansible is running. A step that is also scripted is like installing the one deploy um, Ansible collection dependencies. I already have it installed, so it ran pretty fast. So if you run it for the first time, it should take a bit longer. Um, the Ansible version that I'm using is 2.16, which is still one of the supported versions. It might work or might not work with uh, older or newer versions of Ansible. Um, all of the versions that I've used are stated on the README document in case something doesn't work. And also for one deploy, I recommend using a stable version, like a tag. For example, I think in this case I'm using 0.10, which is an old tag, but it was the only tag available at the time that I started working on this tool. It might or might not work on newer tags, so just be aware. And now it's going through all of the Ansible roles that we have installed or we have defined. In this case, first it sets up the Nginx reverse proxy role of the infrastructure, because this is a pretty important support role for the rest of the project components, since it will act both as the reverse proxy, so you can access the APIs that are exposed by the Cloud Manager and the provisioning engine, but it will also act as a NAT gateway uh, for all of these EC2 instances as well. I didn't set up any particular NAT gateway on the AWS because we wanted to avoid vendor lock-in as much as possible. So this this EC2 instance is also acting as a router. So that is also explicitly set up in the Terraform AWS files. As you can see, I didn't pass the SSL certificate, so it is generating on its own. Yep. Okay, now it finished with this Nginx reverse proxy component. That's one of the out of the four things that we need to set up. Now it is installing the Cloud Edge Manager, but before that, it is setting up the Cloud Edge Manager routing to use this Nginx EC2 instance as a router. And now it is running one deploy. This is like not something particularly interesting project-wise. You can take a look at one deploy, how it runs, but it will set up a Nebula according to the inventory file that we define, and it is not really complicated because it doesn't have high availability or any fancy deployment. It's just pretty much a stock front end and with Enterprise Edition and what else? And Prometheus enabled as well. That's the only fancy thing that it has enabled, but it's not a complicated deployment file. Let's take a look. If we can, because when running the deployment, you can see it generates part of the tool. It generates an Ansible configuration file and an inventory file. Let's take a look at the inventory file. Let's see, this ingress role is the Nginx proxy I was talking about. This is the hostname that AWS provides for us. This is like the IP needed for the redirection that is performed by the reverse proxy. All of this is output of the Terraform AWS step. Then this is pretty much one deploy, what we pass to it. There are some Docker variables over here in this case, because like we don't have root access to Ubuntu images on AWS, so we have to use the Ubuntu user, and also since we don't have direct access to these VMs because they don't have public IP, it's just the proxy, the reverse proxy is the only one that is publicly available. We have to use an SSH jump to access those VMs. So in this case over here, this is not part of one deploy, but it is a front-end variable that one of the roles that I created uh, uses to set up this AI orchestrator as an external scheduler. Um, this template is, I think, is a one deploy limitation. We don't actually use it, but if you don't define it, then it fails. It probably doesn't fail on a newer version of one deploy. Then over here we have the definitions for the AI orchestrator role. Um, then the provisioning engine. Yeah, this is pretty much the inventory file. This file doesn't exist on the repository. It is automatically generated when you run the deployment, and also the Ansible configuration file is dynamic as well. So as you can see, it puts the Ubuntu as the remote user, and these files are also part of the git ignore. You can then like clean them this file. This you can scroll backwards. You can run the clean step afterwards, and this will do mainly two things: remove everything from AWS using Terraform destroy, and then it will remove the temporary Terraform OpenNebula files that are created afterwards, and then it would also remove this Ansible inventory file and the configuration file as well. So let's take a look at how the deployment is going. So now you can see it finished with OpenNebula itself. This is one deploy. It ended up over here. And now this is the stuff that needs to be performed on Cognit specifically, but on the Cloud Edge Manager. In this case, we have an authentication driver based on Biscuit that we've been working on recently. So it is setting that up. We also have like this OpenNebula extensions repository, which is like a bunch of patches that we need for the project use cases. It's applying all of that. Uh, then it's also setting up the external scheduler. And what else is doing now is setting up the provisioning engine. This is also it also has its dedicated host. The provisioning engine is pretty much a Ruby server, so it's like installing all of this Ruby stuff on Ubuntu that can take a while because some you need to install GCC and a bunch of stuff. So let's take a look also like while that is being set up to the other variant of the deployment file, the bare metal. In this case, you don't need the only thing that you need to state is this bit over here. These are host names for each of the roles. We have, like as mentioned before, this is the Ingress controller, which is the reverse proxy that provides access to all of these machines, and you need to be able to access all of these. Not necessarily these. You need to access these through this one, and then the only thing that you really need besides the infrastructure already set up is the enterprise edition token. If we compare this to the other AWS, you can see like the minimum required things are different, but the only thing that remains the same is the EE token. So in this case, the deployment is simpler, but the complexity then it is based on the user itself, because you need to prep these hosts to be readily accessible by the Ansible controller. Let's take a look at how this is going. Okay, so the provisioning engine, it's already installed. Yeah, you need to install it, and then you need to point it to the front end that is running. So because it needs to access the OneFlow and the 1D API. Now it's setting up the AI orchestrator, which is the last host or role of the project components. Um, First, like if you notice, like every role has like these steps first, and these steps is using this Ingress controller Nginx proxy host as a router. Is the only thing that it really requires, because otherwise these VMs uh, cannot really access the internet, and you'll see that also on the Cloud Edge Manager at the beginning of the log. By the way, all of this information being printed on the standard output, it's also being written live to this OpsForge log. Uh, just in case, like if this is they can compose over here as well. Because there might be an error, and you might close the terminal, and you can always take a look at this OpsForge log, and you can see, for example, this is what happened with Terraform at the beginning. There's a lot of information that you can take a look at. It's especially useful for debugging, because sometimes you might have an error, and then it might go ahead. So this file will also be deleted when running the cleanup step out of these files, and then yeah, it's right now it's running Docker Compose. This might take a while because the AI orchestrator has like multiple Docker containers defined on its role. So there's a lot of image pulling that might take a bit, and also like setting up the containers. But then after that, what is going to be run is the Terraform AWS provider, and that will populate the the Cloud Edge Manager database with also data stores with the required application data that you state uh, over here. Yes, you can define a set of applications to populate, and if you don't define this, then the yes, this is what the schema is defined. If you don't define this, then it I don't think we have defaults. So yeah, you have to define them. A URL with where the image is like readily available. And in this case, it will set it up. Let's take a look at, well, this is being deployed. Let's take a look at what we have. So in this Terraform, we have to, okay, let's take a look actually before to explain the project layout. So then this Ansible directory, pretty much what there is this one deploy is a Git sub module. So when you clone the repository, you have to update initialize the sub module for it to work. And inside this, there's one deploy, and then on playbooks is all of the things that we have defined for the custom Ansible scripts that we have defined for the project. As you can see, there's two playbooks. This uh, this COGNIT playbook is the one that we're running right now, and it will reference a lot of the roles over here. And as you can see, here's where it references one deploy. And right now it is on this stage, so it's almost done. And then the other playbook is the Kiwi playbook, which is the one that builds the serverless runtime application that you can then pass to this. Then the rest of the files, these Kiwi and the files, these are like, I don't think these are even part of the repository. I think this is like stuff that I added. Uh, and it's probably like on the git ignore, but the important ones are these two, which are dynamically generated. Then on the Terraform, we have a directory, we have two directories. Is AWS and Open Nebula. And in this case, um, we have like these files are static, but then like these are automatically generated by the OpsForge tool itself. Um, you can take a look at the variables that it defines over here, for example, and this is uh, stuff that is used behind the scenes to only allow access to the API of 1D, specifically where the Ansible controller runs. And then you can take a look at also like the variables that we define. Like most of these variables can be overwritten with the YAML that you specify at the beginning. And then finally, on the OpenNebula providers, what it will do. Mm, we have basically a bunch of images and where they are pulled from. Yeah, and if you don't provide the default, it will be pulled from over here. This is like a dummy, like a placeholder. Uh, but you can override that on the YAML that you pass. Let's take a look. Okay, so it finished. The last service is quite fast because it's just like issuing API calls to OpenNebula. And what could take long is the image process import to the image data store, but that is also like run async, so that the Terraform doesn't really take long. Let's take a look at what happened. So this is the task that took the longest, and this is the report of Ansible at the end. Now this is like Terraform Open Nebula step being executed, and as you can see, it is adding an image, then yeah, more images, and there should be like yeah the function as a service template, and at the end, the tool also will give you a report of what to do and how to access certain things. This is how the infrastructure in general like will look like, and this is like where to access the web, where to access the other web, the provisioning engine API, how to connect, and all the things are in place. And then you have to like if you actually want to run services, runtimes, appliances, you have to create the KVM nodes, but those are not within the scope of this tool. So let's take a look. Let's see if I can add another thing. Well, let's check SSH access first. So it says I need to connect here with the Ubuntu user using the provider's SSH key. But then I need to jump first. So I need to jump first on this Ingress controller. Oh, no. Jump host loop. Oh, I think okay, I didn't. All right. I know. I added the same host twice. Okay, so this is the Ingress controller. Um, you can see we have Nginx and all of the redirections that it does. As you can see, it will force HTTPS and it will redirect to Sunstone and FireEdge and the provisioning engine. And now, where is let's access OpenNebula itself. Is this so? You can access from over here, or actually no, you can't. But you can use that host to jump or using your SSH key, and this is OpenNebula itself. You can see, okay, on the templates, we should have some, each for the use cases, one flow template list. We should also have like each of these. And then all of the images should be ready as well. They are those images are really like the TTY Linux appliance. It's not really like an actual image, but you can override that if you pass it to the YAML that we discussed before. Um, and now let me stop sharing my screen and let's try to access the any of these like web components. Let me click over here. Okay, let me share the screen again. Share screen. Yeah, okay, so this is the SSL. Like since we don't have a certificate authority, but it is getting SSL. My browser just doesn't trust it. And this is the if you notice, like this is the reverse proxy IP, the public IP, or the host name associated to the public IP. And what password did we issued is like auto generated, so we have to take a look at the one file in the Cloud Edge Manager file system. All right, so the password being auto generated, it should be okay over here, and then you log in and we can see everything. So pretty much this is the scope of the project. Automatically deployed all of this, and then like it probably will change in the future, but this is what it does right now, and hopefully it is clarified.